If you've ever stood in the middle of a 3D printing project wondering whether the filament you're feeding your machine is really worth the hassle, you're not alone. Most makers start out hoping a new extruder will magically solve clogs, improve surface finish, and let them experiment with every color they can think of, only to end up juggling jams, inconsistent prints, and a pile of half-finished prototypes. The real decision isn't about chasing the longest feature list, it's about finding something dependable enough to sit on your desk day after day, easy enough to keep running, and priced so that you're not constantly digging for extra cash. Link is in the description if you want to check the product details on Amazon. The 3dpany C1 is marketed as a waste recycling extruder that can take raw plastic pellets, melt them, and spit out up to 400 grams per hour of filament in any custom color you choose. On paper that sounds like a dream for anyone who wants to run a small in-house filament shop, but the practical reality of using a unit like this is a bit more nuanced. First, you have to consider the space and workflow you already have. The C1 sits on a standard tabletop, but it requires a stable power source, a well-ventilated area to handle the heat, and a fairly disciplined routine for loading pellets, cleaning the nozzle, and monitoring output. If your workshop is already cramped or you're juggling multiple printers, adding a hot melt extruder could quickly become a bottleneck rather than a convenience. Who should actually think about buying the C1? If you're a hobbyist who routinely runs out of filament in the middle of a print and you've got the patience to experiment with raw plastics, this machine could be a game changer. I've seen makers turn plastic bottle caps, old PLA scraps, and even waste from failed prints into fresh filament, cutting down on material costs dramatically. For those who love tinkering and don't mind spending an hour each morning preparing the machine, loading pellets, checking the temperature, and troubleshooting occasional clogs, the ability to produce custom colors on demand is a genuine value add. The C1 also appeals to educators who want to demonstrate recycling concepts in a hands-on way. Having students watch a pellet turn into filament can be a powerful lesson. On the flip side, this isn't a plug-and-play upgrade for someone who just wants to swap out a stock extruder and keep printing. The rating on Amazon is a modest 2.8 out of 5, which tells me that a number of early adopters ran into issues that weren't fully resolved by the manufacturer. If you're looking for a set-and-forget solution, or you have a tight budget where every dollar counts, the C1 might end up being more of a cost center. It also isn't ideal for people who need absolute consistency in diameter and roundness, because you're feeding raw pellets. The resulting filament can have slight variations that affect print quality, especially when you're printing fine tolerances. Let's walk through a typical day with the C1. You start by measuring out about a pound of PLA pellets, maybe a mix of colored bits you've collected from older prints. You feed them into the hopper, set the temperature to around 200 C, and let the machine do its thing. After roughly 10 minutes, you're seeing a thin strand of filament emerge, which you guide onto a spool. The first batch usually runs smooth, the extruder's heating element is responsive, and the motor pushes the molten plastic steadily. However, after a few hundred grams, the nozzle can start to accumulate residue, especially if you've mixed different color pigments. That's when you need to pause, let the unit cool, and clean the nozzle, something that can take 1,520 minutes if you're not quick with a brass brush. Skipping this step leads to inconsistent filament diameter, and the next print might come out with visible blobs or under extrusion. One strength that does shine through is the ability to produce filament in colors you can't buy off the shelf. I tried blending a small amount of orange pigment into a batch of clear PLA and ended up with a pastel hue perfect for a prototype case. The visual result was spot on, and the process gave me a tangible sense of ownership over the material. For creators who like to match branding colors or experiment with translucent effects, that flexibility is worth the extra effort. But the practical weaknesses are hard to ignore. The C1's output is capped at 400 grams per hour, which translates to about a 2 kilogram spool after a full workday. Good if you're printing large parts, but not ideal for rapid prototyping where you might need multiple spools of different colors in a single afternoon. Moreover, the machine's control panel is fairly minimal, a simple LCD with temperature and speed settings, so you have to rely on manual observation to gauge filament quality. There's no built-in diameter sensor, so any drift in thickness goes unnoticed until you test the spool on a printer and see the problem. In environments where temperature control is inconsistent, such as a garage that heats up in